Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Visible Arrows 5 by MD88 Keys, or as I like to call them, Dr. Piano. Here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that each row, column, and designated 9-cell region, which in this case is a box, contains the digits 1 through 9 once each. We have counting circles, where a digit in a circle indicates the number of circles which contain that digit. So for example, if this was a 3 here, that would mean there are 3 circles that contain a 3. So you could have something like 3 here, and not 3 here, 3 here. This would be valid because you have 3 circles which contain the digit 3. And that's the same for every digit that's in a circle. So if you had 5 in a circle, you would have to have 5 circles which contain the digit 5. And those are examples of how counting circles work. We have arrows where the digit in a circle also equals the sum of the digits on the attached arrow. So for example, if this were say 1 and 2, that would force this to be 3 because the sum of these two digits must equal that digit there. So that's an example of how arrows work. And finally, digits may repeat on an arrow, assuming it satisfies normal Sudoku rules, right? So obviously you cannot have a repeat here, you cannot have a repeat here, etc., etc. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. How many, first with counting circles, I like counting how many circles there are so that we know how many digits, how much the digits in the circles must sum up to, right? So we have 2, 4, 6, 8, 10, 12, 14, 16, 18. There are 18 circles here. How many different ones are there? We know there's at least 3 different digits because there are 3 different circles in column 3. We know one of the digits has to be from 6 through 9. Actually, 2 of the digits have to be from 6 through 9. Because one of them is here, the other one is here. And they are the sum of 3 unique digits at least, which is the minimum 1, 2, and 3, which adds up to 6. So this is 6 through 9, and this is 6 through 9. This is also 6 through 9, but it could be a different one. It could be one of these two. In fact, it actually has to be. It cannot be a different one here. Because if this were a different one, the problem is that these, it would have to be 6, 7, and 8 adding up to, which is 21. So you'd have to have 6 sixes in a circle, 7 6 sevens in a circle, and 8 eights in a circle, which is not allowed. Where else are we required to have 6 through 9? We have to have 3 unique digits in. So this is 3 unique digits. So this is 6 through 9 here. Do we have 3 threes? We could have 4 digits. We have to have a minimum of 3 digits in circles. So it could be 5, 6, 7, 4, 6, 8, 3, 6, 9. 3, 7, 8, 2, 7, 9, 1, 8, 9. Or, hmm. So this must add up with this digit to add up to at least 15, because the sum of these arrows is at least 1 through 5, which is 15. So this is 6 through 9 also. Same here. This must be 6 through 9, because the sum of these digits is at minimum 15. Um, do we have any other ones? Not particularly. So these digits have to be, we have 1 through 6, 1 through 6, 1 through 6. Oh, interesting. So these are the sum of 1 through 6, period. Also, anytime you have 3 unique digits add up to another digit. So this is fairly common because we often have this sort of rule. It's not a rule set, but this sort of additive property here. So anytime you have 3 unique digits adding it up to another digit, which is pretty common. You'll see it often in arrows. You'll see it often in lines where you have equal sums. You'll see it in various different mechanics. Sometimes it'll just be like 3 digits in a cage adding up to 9, or to a different digit that's less than that's a single digit essentially. You're guaranteed to have 2 digits from 1, 2, and 3. And because the possibilities are 1, 2, 3, obviously, which adds up to 6, 1, 2, 4, which adds up to 7, 1, 2, 5, and 1, 3, 4, which adds up to 8, both of which contain 2 digits from 1 through 3, and 1, 2, 6, 1, 3, 5, or 2, 3, 4, adding up to 9. Those are the only possibilities. So we're guaranteed 2 digits from 1, 2, and 3 here. We're guaranteed at least 1 digit here because this could be 1. And therefore, since this digit is guaranteed to have 1 digit from 1, 2, or 3 here, 2 digits are guaranteed here. This cannot be 1, 2, or 3 here. So this must be a 1, 2, 3 here. This is 4, 5, 6, and these must be 1, 2, or 3 here. So one thing we know is this can't be 6 because that would add up to 1, 2, and 3. We also have a 1 through 6 sextuplet in column 1, which eliminates 1 through 6 in the rest of the column. So this cannot be 6. This can't be 6. So therefore, this becomes a 7, 8, 9 triplet in column 1. So it's either 7 and 8, 7 and 9, or 8 and 9 for the high digits in the circles. It can never have 6 because that would require 6, 7, 8, and 9. So this can't be 6. This can't be 6. We do have a circle in every row, column, and box. Yes. So this can never be 6. This is, again, 1 through 6 here. These have to be 1 through 7. And it will contain a digit that's 4 or less. So it could be 4, 5. But what it cannot contain is 8s, because 1, 2, 3, 4, and 8 add up to... Oh, this could be the 19. Okay, so we don't actually have that restriction there. This could be 9 and 9. It's at minimum 15, but this could be 9 and 9. Okay. So this digit, whatever it is, we're going to mark that as green, must be the same as this digit. Right? Because two digits adding up to, okay, so this digit then has to be one of these two. Does it? Maybe not. So these are all 3 through 9 with two unique digits. This is 3 through 9. This is 3 through 9. This could be many things. This is at least 4 through 9. But 4, 7, and 8 can never add up to 18. It adds up to at least 19. So this has to be a 7, 8, or 9 here. This could be 3 through 9. So 3, 8, and 3, 7, and 8 does add up to 18, so that's fine. This is 2 through 9 here, because it could be 2 ones here. But that's not possible. So say this was 2, and this is 1 and 1. Then this would never have 2, this would not have 2 and 1 available. It would have to be at minimum 3, 4, 5, which adds up to 12. So this cannot be 2. It can't be 3 for the same reasoning, because if this were 3, the problem is... Right, so these 3 at minimum add up to... Sorry, at maximum add up to 18. This cannot be 3, because if this were 3, that would be 1 or 2 here, and this would not be able to have 2 digits from 1 through 3 then. So this has to be 4 through 9, but again, if we have 4, 7, and 8, that adds up to 19. And the same with 5, 7, and 8, same with 6, 7, and 8, so this cannot be, this has to be 7, 8, and 9. So green has to be one of these two. This is 1, 2, or 3. Oh, interesting. Because you can only have 3, 7, and 8 at minimum, sorry, at maximum with a 3, adding up to 15, or sorry, 18, because this already adds up to 15. So this must be 1, 2, or 3. Same with this. I mean, technically, this could be the 7, 8, or 9. Yes, technically, this actually still... Oh, no, it cannot be. One of these has to be from 1 through 3, right? Because 2 of these at least add up to 15. And then the other one has to be 1, 2, or 3. And if this is 3, that would force us to be a 1, 2 pair, which means in this box, these would be 2 digits required to be from 1 through 3. This would be 3, and that would be 1, 2, or 3. That would be too many there. That'd be 4. So this cannot be 3, therefore it can't be 4, 5, or 6. It's 7, 8, or 9, which forces this to be the 1, 2, or 3. But, again, it could be different ones. These don't have to be the same digit. They could be, but they don't have to be. So this is 1, 2, or 3. These two digits, 2 of these digits are from 1, 2, or 3, so this cannot be 1, 2, or 3 here. This must be 4 through 8. Same with this. This is 4 through 8. Which means this is 1 through 5 here. This is 1 through 5 here. This is 1, 2, or 3, so these digits must be... They have to be 3 through 9, but the problem with that is if it's 3 through 9, say it's 3, then you'd have 3 with 1 or 2, and then 2 digits adding up to 15, which is not allowed. So this has to be 7 through 9 also, and 7 through 9 here. That's the same reasoning for this. Okay. This could actually be 3 through 9 here. We don't know. This could be 3 through 9. Okay. One thing we cannot have then is... Oh. It cannot be 189. If it's 189, this would be 1, and this would have to be 1 also. So it's either 279. It can't be 1, 2 either. Because the only other possible 2 would have to be here. So it cannot be 1, 2, 7, 8 either. So this can never be 1. So this is either 2 or 3. And it's the same digit. Right? Yeah, it has to be the same digit because again, this was the only possibility to be another 2, and it can't be there because of the way that the box works. So, interesting. That means this box has to have a 1 here. This has to have a 1 here, so this cannot be 1 here. This could be 1. That could be 1. Hard to say. This has to be the same as that. So you cannot have 189. So it's either 279 or 378. So we're guaranteed one of these is a 7. So this is guaranteed to be 7. One of these is 7. So one of these two is 7. One of these two is 7. So this cannot be 7 here. So one of these two is 7. 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 So we have a 7 here, so that's 1, 2, 3. Or 1, 2, 3. So it's 3, 7, or 8, or 2, 7, 9. Again, it cannot be 1, 2, 7, 8 because we didn't have another place for the 2. These are the same digit, so we're going to mark those as red. Red cannot be here, or here, or here, so red has to be one of those two. Red cannot... Where is red, then? Red can't be here. Red has to be somewhere here, so this can't be red. So this is red here, which makes this a 2, 3, so this can't be 2 or 3. Red can't be here. Red can't be here, so red is one of those two. Red is not here, so red is one of those two here. Red can't be here or here, so red is one of those 4. Red can't be here or here, so red's one of these 4. Green. So I don't think this can ever be 3. Right? If this is 3, yeah, that would be 8, 7, 8, 9, 7, 8, 9 here. So this has to be 7, 8, or 9. So this is green. We're going to mark this, I don't know, as dark. So green and dark, so that forces this to be green, which forces this to be dark. So green is, so then we don't know which ones these are. This could be dark, we don't know. This has to be green and dark in some form. So this must be dark then. So this is dark and green. So this cannot have a 7 here. What else? This can never be 9. If we have a 9 in a circle, the 9 in column 4 has to be this one, so this can't be 9. If we have a 9, again, if we have a 9 in a circle I guess this does have to be 9 here, if that's 9. Interesting. The rest of this box cannot contain 1 through 3 or 7, so it's 4, 5, 6, 8, 9. The rest of this box cannot contain 1, 2, 3, or 7, so this is 4, 5, 6, 8, 9. One of these has to be a 6. And if one of these is a 6, it's guaranteed to be with 1 and 2 in the same box. So since one of these is guaranteed to be a 6, we have to have a 9. So it has to be 2, 7, and 9. So the reds are 2s. We don't know which one this is. So we don't know which one's this one. We don't know which one this one. We don't know which one this one. So these have to be 2. So this is 2. This has to be 7 and 9. That means where's the 9 in column 4? It must be here. Where's the 9 in column 6? It must be here. There's a 9 in column 5, then it has to be here. So that makes this 7, which makes this a 9. That means this can't be... This is 9, so this must be 7 and 9. And this can't be 9, so this is 7, which makes that 9, which makes this 7, which makes that 9, which makes that 7, which makes that 9. So this is 7, this must be 9. This 9 eliminates 9 here, so it's 7 and 9. And the reason why, again, is 6 has to be in one of these 6 cells on the arrow. And 6 can only add up with 1 and 2 to add up to 9. So we're guaranteed a 9 here. So we have all the 9s, we have all the 7s, and we have all the 2s. So we need to fill up, so this has to be 7. Where are the 7s then? We should have remaining 7s. 7 in row 4 has to be one of these two. 7 in row 7 has to be one of those two. Because those are the only places remaining. We have 2s. This can't be 2. So this cannot be 2 here. It's 1, 3, and 5, adding up to 9. That eliminates 5 and 9 in the rest of the box and the rest of the column. So this can't be 5. This can't be 5. This can't be 2. To add up with 4 and 6 to add up to 9... That means it must be 1, 2, 6, or 2, 3, 4. So you're guaranteed a 2, so this is 2 here. So this can't be 2 again. This is 1, 3, 5, adding up to 9. That eliminates 5 and 9 in the rest of the box. This is either 1, 8, no 2, 7, 3, 6, or 4, 5 here, adding up to 9. Same with this. 2 cannot be here. So this adds up to 7. So this has to be 4 and 6 with 1 and 3. Seven. This can't be 7 because there's a 7 and another digit can never add up to 7. So this must be 7 here, which eliminates 7 here. So this is 7 here. To add up to 9, this has to be 1 and 1 here. So that eliminates, this again cannot be 8. This is 1 and 3 adding up with 4 and 6. So this must be 3 and 4, which eliminates 4 in the box. This 1 eliminates 1 here. This 1 eliminates 1 here. So that forces this to be a 1 here. This cannot be 1, 6, or 2, 5, adding up to 7. So this has to be 3 and 4, which eliminates 3, 4 in the rest of the column. This can't be 3. This is 5. That's 3. That leaves this as a 6, 8. This cannot be 1, 8. Cannot be 3, 6. So this is 4, 5, adding up to 9. This cannot be 2, 7, adding up to 9 because of the 7 in the box. So, where is the 2 in box 8? Cannot be here, cannot be here, cannot be on the 9 arrow because we require 7 to add up to 9. So this must be 2 here. Which leaves, where is 2 in box 9? It has to be here because it can't be here, and none of these work. That means we have 8 2s. We know where the last 2 has to be. It has to be there. 1 and 3 cannot be here because of 1 and 3 in the row. So this is 5, which eliminates 5 here. Interesting. This is 1, 6, or 3, 4. And this is 1, 6, or 3, 4. Either way, this cell will see both 1, 3s here, right? This one from just being in the same row, this one from being in the same column. So 1 cannot be in either this box here. Whereas 1 in row 4, then, it has to be here. Because again, if we have 1 here, that would force this to be 3, 4, and 3, 4, and we'd have a contradiction there. So this must be 1 and 6, which makes this 4 and 3. This can't be 7 or 9. It's 8. This 3 eliminates 3 here, so it's 4 and 3. Whereas the 1 in row 3 cannot be here, because of 1's in the column, so 1 has to be here. Remaining digits in row 3 are 5 and 6. This can't be 5 because of the 4, 5 pair in the box, or the column, so this is 6, this is 5. This adds up to... Wait, that doesn't work. Oh, this is 1, 2, and 4. Whoops. That's the reasoning. Okay. So this is 1 and 4. Apologies for that. So then this is 6 and 1. Okay, there we go. So this is 8. Okay, then everything's still kosher. This is 1, then. Interesting. Huh. Yeah, I totally missed that this added up to 7. This adds up to 9. You cannot have 1, 8, 2, 7, or 3, 6, so this is a 4, 5 pair. This cannot be 1, 8, 2, 7, or 4, 5, so this is 3, 6 as a pair, adding up to 9. This cannot be 1, 6, or 2, 5, so this is 3, 4, which 4 eliminates 4 here, so this is 3. That's 4 to add up to 7. This is 2 and 5, adding up to 7 here. So this cannot be, this is either 1, 8, or no 5. So this 5 eliminates 5 here, so that's 4 and 5. 4 eliminates 4 here, so it's a 6, 8 pair. The 6, 8 pair eliminates 6 and 8 in the rest of the box. So this can't be 6, this is 4, and 3 adding up to 7, which makes this 1, which makes that 3. So this cannot be 3, 6, 2, 7, or 4, 5. It's definitely 1, 8, which eliminates 1, 8 in the rest of the row. So this is 6, this is 8, this is 6. Remaining digit in box 1 is a 3, so that's 3, which eliminates 3 here, so it's 4 and 3. This 3 eliminates 3 here, so it's 6 and 3. This 6 eliminates 6 here, so it's 8 and 6. 4 eliminates 4 here, so it's 5 and 4. That leaves this digit as a 5 and this digit as an 8. That leaves this digit as a 5 and this digit as a 6. Remaining digit in row 4 is an 8. So that eliminates 8 here, so it's 1 and 8. Remaining digit in box 9 is an 8. Remaining digit in column 8 is a 6. Remaining digit in row 3 is a 5. This must add up to 7. It's 1, 6, or 3, 4. Remaining digits here. So this is 1, 6, or 3, 4. Cannot be 2, 5. Remaining digits adding up to 9 are 1, 8. Cannot be 3, 6 because that would eliminate all possibilities for this arrow. So this is 1, 8, or 4, 5. And this cannot be 5 or 8, so this can't be 1 or 4 correspondingly. This can't be 1 or 3, so this can't be 4 or 6 correspondingly. Remaining digits in row 7 are 4 and 6. This can't be 6 because of the 6 in the column. So this is 4, that's 6. 4 eliminates 4 here. So this is 1 and 8 adding up to 9, which makes this 3 and 4 adding up to 7. Remaining digit in column 4 is a 5. Remaining digit in column 6 is a 6. Remaining digit in row 2 is an 8. Remaining digit in row 1 is a 1. And that's a solution. Interesting. Yeah. I guess I should have probably been able to find this faster. Because we're guaranteed a 6 here, right? So that should have notified me almost immediately. I don't know. I was just a little slow. I hope you enjoyed the solve, though, and I'll see you next time on Frank Puzzles. Take care.